Hi there, folks. Today we're looking at nets and drawings for visualizing geometry. And the idea of visualizing things can be a little tricky in terms of learning it because it's not as concrete as some of the other things we've done in math, where we have this set of rules. We're kind of just using our imagination to reconstruct things and see what it looks like in our heads and then try to interpret that as a drawing, okay? So the first thing we're going to look at is a net. A net is basically a two-dimensional diagram that can be folded up back into a three-dimensional diagram. So if I had a three-dimensional shape and I cut it open and spread it out flat on a piece of paper, that's what a net would look like. And so the idea behind this is we want to look at the net and see if we can reconstruct the three-dimensional shape by putting the pieces back together, all right? By folding it back up and taping it back together, that kind of thing. So if I look at like this first one, the idea here is if I start thinking about how I could fold these pieces, like if I took this piece and I folded it up on the end, let's say if I labeled these A, B, C, D, how about E and F, just as a way for me to talk about this thing. If you kind of visualize D being folded up off of this piece of paper and E being folded up and F being folded up, and then if you folded up A and B together and then folded A back down on top, the shape that you end up getting is kind of like a little box, all right? And you've probably seen examples of these in real life when you've looked at like a box that's been cut up and like you rip the tape off, and you flatten it out. You can easily recreate those folds and fold the box back up, all right? But in the example that I described, C is kind of on the bottom of this thing, and you see like D is over here, F is here because it got folded up. E is at the back of this thing. All right. Again, C is down here at the bottom. A is on top because it got folded, doubled over, and B is off to this side. So again, it's that idea of can I reconstruct the three-dimensional shape from the two-dimensional figure? All right. That one might be a little bit on the easier side. This one might take a little bit more imagination if you look at this thing, because one of these isn't necessarily going to be a fold. So again, if I kind of label these pieces, I'll call this A, B, and I'll call the big piece C. All right. If you visualize the idea of folding A up off the paper and B up off the paper, all right, so I have a flat sheet of paper with two circles folded up sticking into the air. Now instead of folding C in a exact sense, think about kind of rolling it up. If you rolled C up, all right, you would kind of get this cylinder type shape. So if you kind of folded A up and you folded B up and then you rolled this whole thing together, you get something that kind of looks like this, where you have A on this end, you have B on this end where you can't really see it right now, and then C, that middle piece, is us rolling this into kind of that curved shape. All right. But that's the idea behind a net. If I took a three-dimensional shape, I cut it open and spread it out flat on a piece of paper, that's what a net is. And can we take that net and reconstruct it back into the three-dimensional shape? It's visualization. Okay. It takes a little bit of imagination. All right. And so now let's talk about drawing some of these three-dimensional shapes. The way we draw these a lot of times is using an isometric drawing, all right? An isometric drawing is a drawing that shows a corner view of the three-dimensional shape. When we draw things from a corner, and when you look back up at the previous examples here, if you look at that box that I created, that's basically like a freehand isometric drawing is what I have done there. Okay, it's a corner view, and even though I'm drawing it on a two-dimensional piece of paper, I'm trying to make it look like a three-dimensional shape. That's what isometric drawings help us to do. All right, and that's the thing that's tricky. And the reason we do it this way is because it's tough to make something look three-dimensional. All right, when you're drawing it on a piece of paper, because a piece of paper is two-dimensional. All right, for anybody who's ever taken an art class, maybe you're pretty good at this. All right. They use this a lot in like engineering and that kind of stuff, all right? So if I take a look at something like this guy, when you look at these dots, this is kind of what isometric paper would look like. It's got these dots filled in like this. And what we can do is we can draw this thing. So like to draw the top of a box, we do this. See, that's the top of a box, and then there's the sides of the box. See, that's that top cube that I have off to the side here, okay? And then the next cube is that blue one, which is this guy. And then I also have another green one down here, okay? And what some students maybe sometimes like to do, see, I've kind of just taken that shape that I see off to the side, I've turned it a little bit, so I'm looking at it from kind of that corner angle. But what some folks like to do is they like to draw each of these separately. For example, like if I came off to the side and said, okay, let me draw the green box by just filling this whole thing in. The idea here is like when you look at this one, I can't see this back corner, so I wouldn't typically draw that, or I can't see, this bottom piece right here. But if that helps you visualize, you can kind of draw those as dotted lines. The other thing that students will sometimes do is they'll say, okay, here's the top of the blue box, and they'll draw this guy as one complete box. And they'll say, okay, here's the top of the next green box because it's touching the bottom of the blue box. And so they'll kind of draw each of these pieces together, but you can see that kind of looks messy and I can't distinguish. If you draw it that way, you have to go back through and erase those pieces that you don't need, okay? You have to erase the green off of this guy, all right? And you have to erase these back pieces to try to make it look more like the drawing, all right? Up here, you have to erase the blue, all right? That can be a little bit cumbersome, a little bit tedious. As you get practice with these, you'll start to realize that you start from the top and work your way down, because the top is the pieces you see, and then you draw those vertical pieces going down. Same thing with the next one. Like, again, start with the top. The top is the red block. So let me start with the top of the red block. Here's the top of the red block. Okay, and then I draw the pieces of the red block going down. But notice I don't necessarily draw the entire back of this thing and that kind of stuff. So there's the red block sitting on top. Okay, and so now I have to visualize and say, okay, at one side of this thing is the blue block. So here's the blue block coming off to the side. And again, I draw the top of the blue block. And then I can draw the pieces of it going down and the bottom of it. Okay. And now think about where the purple block is in relationship to all that. It's on the other side of that red block. So here's the top of it. Okay, kind of bordered right up against that. And there's the pieces going down. Okay. Oh, I almost didn't draw the whole top, but that's an isometric drawing. Okay, we're drawing a visual representation of this thing on a two-dimensional piece of paper, but we're trying to give it that shape and show that it's a three-dimensional shape. Okay. The last thing we're going to talk about is an orthographic drawing. An orthographic drawing is when we take kind of an isometric drawing, we take that three-dimensional shape, and what we do is we draw it from different angles so that we can kind of visually show it in two dimensions from a couple different perspectives, okay? And so what we do is we're going to draw the top. So visualize this thing from the top and think about what it looks like. We're going to draw it from the front, and we're going to draw it from the right-hand side view, okay? So again, we have to visualize from the top. We have to visualize from the front of this thing, which is kind of this angled piece. And then the right-hand side is this guy right here, okay? And so we kind of want to draw this from a couple different perspectives. So if I draw it from the top, so again, we're visualizing what's up here. So if I kind of imagined looking down on this thing, you see that I would see one block kind of by itself, and then I'd have kind of an L-shaped block above that. So the top view of this thing, I would have one block. That's that kind of tall tower sticking up. And then behind that tall tower, I would kind of have an L-shaped, sorry, that's not very good. I didn't go up high enough. I would have kind of this L-shaped looking thing back behind here. So that's kind of what the top view would look like. And again, it takes a little bit of practice to just kind of visualize that and say, okay, yeah, that tower would look like just a block from the top. That piece behind would look like an L-shaped thing from the top, okay? And then I want to do the front, which again is this guy over here. So again, if I were to kind of visualize what would that look like from the front, I would see that tower thing, which is kind of 3 blocks tall. So I'd see that tower from the front. And then next to that tower, a little bit further back, I would see just a single block sticking out, okay? And so I wouldn't kind of get the sense of that L-shaped piece behind when I'm looking at the front. But then looking at this thing from the right, Again, I kind of have to think about what this looked like. Off to one side, I would kind of see that tower, right? And then next to that tower, I would see one block sticking out towards me. And then I would see another block that's kind of further back. Okay. And so these are the different perspectives that we would get: the top, the front, and the right hand side. And the idea here is, all right, when we look at this thing from a three-dimensional perspective, that's great, but it's really hard to label that kind of stuff. And so we kind of use this in things like engineering. CAD drawings will a lot of times do this, where they have a three-dimensional picture, and then they have these orthographic drawings, because when they show the top, the front, and the right, over here, this is where they would put all the dimensions of those blocks, okay? So that it would be much easier to construct the three-dimensional shape from those plans, because it's easier to put those dimensions when we're looking at the two-dimensional perspectives of this thing, if that makes a little bit of sense, okay? So sometimes we use those kind of things in those type of fields, all right? So again, visualization can be a little bit tricky, all right? We have three things we looked at. It was the nets, which is basically like a flat version of a three-dimensional shape after we cut it open and lay it out, all right? So trying to be able to spread those out and to reconstruct them, all right? Then we have the isometric drawings, where we're drawing three-dimensional shapes from that corner view. And then the orthographic is when we go from that three-dimensional shape and we draw the two-dimensional perspectives of this thing. Okay?